Greetings. In this video, we're going to talk about how to analyze and read the text for classifications and misclassifications. So this is the Excel spreadsheet I sent you, and this will set up the problem for you so you can spend your time as analysts really engaging four texts in four different conditions. What we're looking up here is, these are the real news variables, the variables that favor and tend to signal real news, academic information, future, and syntactic complexity. What we've done here is across the corpus, these are averages for fake. So in fake news, academic is distributed about 2.6% frequency, whereas in real news, it's distributed about at 5.7% frequency. Information is distributed about 6.7% frequency in fake news. In real news, about 13% frequency. Future is distributed about 0.4% in fake news and 0.8% in real news. Syntactic complexity, 8.9% in fake news is the frequency, 11% in real news. First person is 0.7. In fake news, 0.1 in real news. If we go over here, we can see the distribution of the fake variables. In first person, fakeness is about, in fake news, first person distributes about 0.7%, and in real news, about 0.1%. Character distributes about 7.4% on average in fake news, and in real news, 4.3%. Now what we do is, these are just the averages that I took from Minitab. I pool the averages, so you take the average of 2.6 and 5.7, you take the average of averages, and it comes out to academic is 4.15, 9.85 is the average of 6.7 and 13, 0.6 is the average of 0.4 and 0.8, 9.95 is the average of 8.9 and 11, 0.4 is the average of 0.7 and 1, and in the fake news variables, distribution in fake and real, 0.4 is the average of 0.7 and 0.1. For character, 5.85 is the average of 7.4 and 4.3. So we take these averages, and these are borderline. These numbers are completely borderline between fake and real. Then we can make a very simplified discriminant equation. It's not as complex as the statisticians actually use with all the math, but this will serve our purposes well. So let's assume that we add the real variable, the average of the real variables here that actually support real news, and subtract. So we put minus signs. We're going to subtract the averages here for the fake news variables. And we're going to get a total. And you can see this 18.3 is just the sum of these numbers. It's just the sum of these numbers here. Yep, sum of these numbers here. You add and subtract the fake variables, so you get 18.3. That's a perfect borderline cutoff. That will be our magic cutoff number. That means if we run the text through the equation with all its numbers and it's more than 18.3, we consider it real. If it's less than 18.3, we consider it fake. So now here are the four texts I want you to actually look at. And I've selected them so they'll work. I put down the averages here so you can see them again and don't have to recopy them. Averages across the corpus based on descriptive statistics. Here's the average. What we're going to do is I want you to, in your write-up, look at four different texts, and I've selected the texts. There's row 83. You don't have Minitab, so you don't have to worry about this. I've identified the text for you. With the text 1, discriminant analysis predicted it would be real. It's actually fake. Text 2, discriminant analysis predicted it would be fake. It's actually fake. So this is a misclassification. This is a correct classification. Text 3, row 557, you don't have to worry about rows. Predicted real, actual real, a real classification. Text 4, row 581, predicted fake, actual real. Here are the titles of the text you can get, because all you have to do is, you don't need Minitab for this assignment, just DocuScope and STV. I want you to open up each of these texts one at a time. Look at the pooled mean averages. This is Walmart banana recall, and it's text 80 in the fake news pile. The computer judged it 80% real. It said the 80% probability it's real, only 20% it's fake, but it's actually fake. And so what you need to do is, I chugged in the numbers here. These are the numbers that you can read in DocuScope STV. And I put in the numbers here for academic, 2.4% frequency, 10.4% frequency for information, 0.8%. And if you add them all up, you see that the score here is 23.2, makes it think it's real and it's fake. So it's above the cutoff and it's misclassified. So I want you to engage that text deeply and explain why it was misclassified, why it is assumed to be real, and how you with the human brain would know it's really fake. Text 2 I want you to look at is in the fake news pile, 0.008 spam Oreos. The computer thought it was 100%. It was confident it was 100% fake, and it is actually fake. And if you go here and you chug in the numbers for the equation, you see that, and you'll find these numbers when you go to STV. You plug in these numbers and you actually see that, lo and behold, the score, the equation totals 16.18 because we, add the real variables, we subtract the fake variables, we get 16.18. That's below 18.3. It's fake, it's a correct classification. I want you to go into that text and explain why it's a real classification, why the computer was right. Text 3, it was predicted to be real, and it is real, so it's a classification. This text is in the Reuters pile, it's number 107. The computer thought it was completely positive that it was a real text, and it was right. Here are the numbers from DocuScope STV plugged in. You can see that the number here is 28.4, very large, way above, so you can see why it was thought to be classified as real, and it was correct. And the fourth text is in row 581 in Minitab. It's Reuters 131. It's predicted fake, but actually real. The computer judged it 53% fake, so the computer itself knew that it was sort of very close and mixed. And so when you analyze this one, you've got to really explain why it seems to have the characteristics. It seems to be a hybrid on the borderline between fake and real, why the computers thought it was right on the borderline. You can see its number is 18.28, very close to the cutoff, and that's why the computer got confused. It called it fake, but it's really real. See if your human brain could actually decide. So basically, for this last part of the assignment, you don't need to use Minitab at all. Just DocuScope STV, get deep into these four texts, and explain how they were classified, what the computer did. If the computer classified it correctly, you can actually say if your brain agrees. And if the computer misclassified it, say if your brain would have classified it correctly. That is it.